Welcome to the next session on functions. What we're going to look at today, we've looked at the straight line y equals mx plus c. We've looked at the hyperbola y equals ax squared plus q. And we've looked at the effect of m, which is the gradient. And we've looked at the effect of c, which pushed it up and down. Then we looked at a, the effect of a in ax squared plus q. Remember, if a was a fraction, it made it flat. If it was negative, it was upside down. It was a sad face. And we also looked at q. And what did q do? Q was essentially where it lifted it up and down. And the turning point, remember, was where it went through the y-axis in this case. Next year, it changes. The turning point moves across to the right or to the left. But don't worry about that at this stage. Let us look at the next graph. Now, what is the next one? The next one, let's just get this sorted. The next one is the hyperbola. Okay. Now, let's look first of all the standard form. Let's say standard form is y is equal to a over x plus q. Yes, I'm aware my a does look like a 9. My a over, there we go, a over x plus q. Right, now, let's let q equal 0 initially, but no prizes for guessing what q is going to do. Q is going to lift it up or drop it down. It's exactly the same as all the others. All it is, it's the vertical shift up or down, all right? And it introduces the concept of an asymptote in this one, okay? Right. So initially, let's just look at a graph. Let's just take the simplest form, okay? The simplest form of the graph is y is equal to 1 over x plus 0, so q equals 0 for the time being, okay? Let's have a look at this. Now, in this case, and a is equal to 1. So this is pretty much the simplest form of a parabola, of a hyperbola that we can get. Okay. Well, let's plot it. Okay. Let's plot it. Remember, how do we do that? We do x and y's, and I'm going to reiterate again while I'm writing -2, -1, 0, 1, 2, and we're going to do some plotting of these. Remember, x and y go together like the proverbial, rhubarb and custard or whatever they say. The point here is that if you've got an x, you can work out a y. If you've got a y, you can work out an x. Please, I know I repeat that, but when we get to analytical geometry, absolutely critical. Or even finding the equations of these lines, absolutely critical. Okay, so let's plot. So I've done them already, okay. That's going to be -1/2. That's going to be -1. Well, let's just leave that for a second because it's 1 over 0. 1.5, right? So let's just have a look what's happening here. Okay. If we want to plot this graph, right, we would have to do our axes, x and y, like so. Okay, x, y, label the origin, remember? And we would plot them. Essentially, what we're going to get, let's just plot 1 and 1 first, all right? It's there. And -1 and -1. 1 and 1 and -1, -1. There. So already we've got a bit of a misnomer here. Because this graph, either it's going to be a straight line, but it's not. Okay? But as we go up and we plot further, we go and we see that 2 is a half, right? And if we plot now a fraction, right, let's have a look at what happens if we plot fractions, shall we? X input, y output. Okay, let's have a look at a half, a quarter, an eighth, and 100th. What happens to x? 2, 4, 8, 100. So hang on, what is happening here? As x gets small, y gets big. All right? Hang on. What is that? That's inverse proportion, isn't it? That's inverse proportion. Those of you going on with physics with me, you'll see that coming in quite a few graphs that we draw. Things are inversely proportional to each other. Okay, so if we now go and plot this, okay, you're going to be doing a lot of these. If we plot, here's my 1, remember? If we're plotting the fractions, the graph is going up, and this one is doing that. Right? Ditto, if I go this side, I get that. This is the proverbial hyperbola. Okay, that's a hyperbola. Now, while we're here, I'm just going to label this Q1, Q2, Q3, and whoops, my Roman isn't that great. Q4, all right? Q1, Q2, Q3, whoops, I put a 3 there. That wasn't supposed to be there. Right, let's just get it out, and a Q, all right? So, hold on. The hyperbola is two separate graphs, right? It occurs in quadrants 1 and quadrant 3, all right? So, this is quite an odd-shaped fellow, and not something that we've come across too often before, okay? So, as you can see, if x gets very large, okay, y gets very small, okay? So you can see the shape, it's what we call tending towards 0, okay? As it gets smaller, it tends towards 0. Right, let us look at the special case. Hang on, let's go through our thing of how to draw a graph. Wait, let's just get rid of this. All right. What do we say? We say let x equal 0. Therefore, y is going to be 1 over x plus 0. Okay, and that's going to be 1 over 0 plus 0. This we cannot have it. All right? So x can never be 0. Okay, x cannot be 0. Well, what does that mean? It means, in essence, it means that the graph gets closer to x equals 0, but just a bit ahead of myself there, but can never cut the x-axis. In other words, it's going to get closer and closer and closer. You remember up here where I drew this? We did the fractions here, remember? Look at this one here. Okay? If x is a fraction, we did that. All right? And we also said that ourselves that, here's the other ones. We said over here, right? We said that it gets smaller as the other gets bigger, and vice versa. So, essentially, it's never going to get there. Therefore, the x-axis is an asymptote. What's an asymptote? An asymptote is a line which the graph cannot cut. Okay, well then, let's have a look. Let's just get a new page. Let's have a look and see to us. Well, let's put y equals 0. Let y equal 0. Therefore, 0 is 1 over x plus 0 in this case. Therefore, we're then saying that x times 0 equals 1. So 0 equals 1. This is patently nonsense. Right? It's nonsense. It can't happen. Therefore, okay, y cannot be 0 either. Which means y-axis is an asymptote. So for a hyperbola, let's draw just the simple hyperbola y equals 1 over x plus 0. A is 1 and q is 0. And our graph looks like, there we go, and getting like that. And we plot these points here, 1 and 1, and minus 1, like that. So, and we put that there, and we say, okay, there we go, x and y. Okay, now I've got it just touching the axis there, which is not really great, so let me just do it. Okay. It means that this x is an asymptote, and the y-axis is an asymptote as well, because the graph never touches it. Okay? Now, let us have a look at something slightly different then. Well, what about y equals minus x? Okay? I'm just filling in the 0 there. I mean, obviously we don't write that, but it's one of... Well, what have we done? We are multiplying each value by minus 1, which means we are doing this to the graph. So now it has gone into Q2 and Q4. Right? So what have we got? We've changed it. We've turned it around. Okay. Well, from this we get the following rules for an asymptote. Okay. For a hyperbola. Firstly, for the hyperbola, A and Q. If A is less than 0, let me start off with greater than 0, right? If A is greater than 0, then it's in Q1. Why do I always write Q2 there? Q1 and Q3. If A is less than 0, then it's in Q2 and Q4. So the A, okay, the A value, just like with a parabola, if A was negative, it went upside down, the sad face, remember? With a hyperbola, if A is negative, it means it goes from quadrant 1 and 3 to 2 and 4. Okay? So you'll see when we plot these, we go through the things again. We say shape, this, that. We apply a recipe, and we basically bake ourselves a hyperbola. All right? Now, create another page, get it back onto the black. Now, so what if we change A, right? If A becomes, let's say we've got a graph of y equals 6 over x plus 0 for the moment, right? Well, what is going to happen here? What have we done is we've actually said that is 6 times 1 over x plus, let's leave out the 0 over there, shall we? That there is, so we've taken every value and we've times it by 6. You can just plot 1 or 2 points. And what you see is that the graph, when you had 1, it now becomes 6, and it used to be 1 and 1, remember? Okay. So now it takes it and it becomes 6. So we've actually kind of stretching the graph up like this, aren't we? We're sort of taking the graphs, okay, this one becomes over there, that was 1 and 1, this one becomes 1, minus 1 and minus 6, like that. So we're sort of stretching the graphs up like that, okay? How do you do that? Quickly, you just say to yourself, okay, plot the x equals 1. So you say, right, plot x equals 1, x equals minus 1, and it shows how the standard point A and B, let's say that standard points A and B, it shows you how they've moved, right? Ditto, if A was a fraction, it's going to bring it down towards the origin, isn't it? Okay? And yes, the Q is going to lift it up and it's going to put it down. Now, just let's have a look before we move on to sketching 1 and Q and things like that. Let's just have a look here. You remember, and let me just discuss axes of symmetry. What is an axis of symmetry? Well, An axis of symmetry is in essence like a mirror, isn't it? Or it's a fold line. So that where we fold it, if we fold our piece of paper along that line, it means that the graph is actually, it goes and it folds on top of itself. So if I had, let us say we have this guy here, all right, and let's say that's 3 minus 3 and plus 9, okay. Now can you see that if we take this line here, let's just have a look, green, and if we took it as a piece of paper and we fold it along that line like that, you can see that this half of the graph and this half of the graph will overlap each other, won't they? So therefore, the y-axis is an axis of symmetry. Okay? Because it's symmetrical. It's the same about that axis. All right. Well, that's great. But now, just a moment. What about the hyperbola? Okay. I'm only drawing the standard hyperbola here. Okay. I'm going to put in our standard point 1 and 1, and minus 1 and minus 1. Okay. And now let's have a look. Let's look for axes of symmetry on this guy. Well, just a sec. The line y equals x is an axis of symmetry. Can you see that? And the line y equals minus x. Because why? Because if we fold it about the line y equals x, this piece of the graph here, okay, this piece of the graph and this piece fold onto each other, don't they? Try it. Draw the one we've just drawn, draw it, and then fold it along that line, and you'll see, hold it up to the light, and you'll see that they actually fold right over each other, and ditto with the bottom part. But the blue line is also, because what happens is this piece folds onto that piece, okay? Really well worth plotting a simple one very quickly and just folding on those two lines, because then you get the feeling for what's actually happening here. Okay? Because axes of symmetry play a big role in the future of what we do with parabolas, hyperbolas, etc. Now, let's have a look at something. Well, first of all, we say, okay, what does Q do? All right, let's go back and say, what is Q? Well, Q we've said is up and down. Okay? Because we're adding it to what we work out, aren't we? Y is equal to something over x, then we just add or subtract a number with it, don't we? That's how we plot our graph. Which means it's going to lift it up and down. Let's take a simple graph. Y is equal to 1 over x minus 2. Okay? Right. Now what do? Well, we can't put x equal to 0, can we? Okay? So therefore, x cannot be equal to 0. Therefore, the line x equals 0, in other words, the x-axis, is an asymptote. Sorry, I was thinking of symmetry. So frustrating when it doesn't work like that. Is an asymptote. Okay? Because x can never be 0. Let y equal 0. Okay? Therefore, 0 equals 1 over x minus 2. Oh, hang on. Now we actually can do it. Plus 2 equals 1 over x. Therefore, multiply through by x. 2x equals 1. Therefore, x equals a half. Hold on. We've got a coordinate. A half and 0. Whoa, what does that mean? Okay? It means that we actually can, okay, let y equals 0. So we get a coordinate. It means that our graph actually cuts the x-axis, doesn't it? Okay? Right, now, let's just rewrite it. Y is equal to 1 over x, and it was, let me just check, it was minus 2. All right. Now, let's just have a look what's happening here. We said that we're taking the standard graph and we are moving it down by minus 2. Okay? So that is going to be 0 and minus 2. All right? That's that line there. Now, we say, okay, hold on. If we plot some numbers here, let's just look at x equals a large number, shall we? Let's say x is equal to 1,000. All right, let's go. Let us say that y is equal to 1 over, let's say 100 minus 2. All right. Now, if we take that, okay, at the point x equals 100, so at x equals 100, we've got the value of, let's have a look, 1 divided by 100 equals that, minus 2 equals minus 1.99. Okay, so at x equals 100, let's say it's way over there, it's minus 1.99. If x is 1 over 1,000, it's actually getting closer to this line here, y equals minus 2. Okay, which means that the line, this here, the q, is actually an asymptote for a hyperbola. Okay, because x can never be equal to 0. We've worked that out already. Well, if you put x equal to 0, let's pretend, we get a very, very small number over there, and y is equal to minus 2. Okay, now, what we're saying is we're saying that it's an asymptote. If you look up above, what did we do? We plotted, hang on, if y is 0, x is a half, correct? If y is 0, okay, x was a half. Like that. Okay. So what we're saying is that this one, if you plot it, actually does that, and I do apologize for this bit going down over there. Let me just lift it a little bit. And this comes down like that. So the whole graph has actually dropped down by q. So in a hyperbola, okay, y equals a over x plus q. The line y equals q is an asymptote. So, no, previously q was what? Q was our y-intercept. Now q becomes an asymptote, okay? It's going to be like that for this one, and it's also going to be like that for the next one, which is the exponential graph. So, okie dokes, now we say, fine. Thus we have dropped the graph. So, minus 2 is the asymptote in this case. Let us now have a look at drawing a graph, shall we? Okay. Let's say, and I've got a graph here, all right, let's say we look at this first, and they ask us, draw the graph of y equals minus 1 over 2x minus, and that's a 4. Okay. First of all, step 1. Identify. Identify the type. It's a hyperbola because the x is underneath over there. So it's a hyperbola. Okay. Then we say, okay, y equals minus 1 over 2x minus 4. Standard form. Y is equal to a over x plus q. All right? Okie dokes. Now we need to manipulate. So we say, all right, let's have a look here. Okay? Let's keep it all under the same step, the standard form. we say that y is equal to minus a half times 1 over x minus 4. Can you see what I did there? I took that minus a half out because I'm looking to identify a. That's where a comes from. So a in this case is minus a half. Because remember we had y equals a over x. That is a over 1 times 1 over x, isn't it? So I've removed it just to make it clear for myself. Obviously, as you do more, you won't need to do that. I'm just showing you where it comes from at this stage, right? When you're starting to, let's say you're getting into this, you immediately will see that it's minus a half, all right? Okay, so therefore now we've got it into a standard form. That's a 4. Right, so now we say step 2 is the shape. Now in this case we know what the shape is, but we're actually saying what quadrants. What quadrants are you in? We look, and if A is greater than 0, it's 1 and thingy. If A is less than 0, it is 2 and 4. 1 and 3, 2 and 4. Okay. Now, therefore, in our case over here, we have said that A is equal to minus a half. Therefore, the graph is there and there. Okay. Now, please, you don't, when you sketch it for the shape, don't put in where it's, asymptotes. All you're doing is you're reminding yourself it's in quadrant 2 and 4. Okay. Just this very simple sketch, just to trigger the mind to say, when you're drawing it, where am I? Oh, I'm in 2 and 4. Okay. Next. Okay. Next is step 3. And Q shows the asymptote. So at y equals minus 4, we've got an asymptote. Right. So, cool. Okay, step 3 is like that. Shows the asymptote there. And step 4, okay. I've obviously, all right, let's just say, let x equal 0, okay. And therefore we've got y is equal to 1 over 0 minus 4. Cannot. Therefore, x-axis is an asymptote too. Isn't it? Okay. The x-axis is an asymptote as well. Okay, cool. Next step we say, okay, minus 4 is the asymptote. Now, we put y equal to 0, okay? Step 5, put y equal to 0, or let y equal 0. 0 is equal to minus a half, okay? Just put the x underneath. X, that's very frustrating when it does that. Minus 4, okay? So let's say that 0 is equal to that, okay? The minus 4 goes to the other side. It becomes 4 is equal to minus 1 over 2x. Okay, let's multiply through. We say 2x times that, 8x. Remember, I just cross multiply here, right? 8x equals minus 1. X equals minus 1 over 8. We write our coordinate down so that we can plot it. And we're almost there, and we can now go and plot this, can't we? All right? And we've got that one, right? So now, last thing is step 6. Plot x equals minus 1, x equals 1, okay? We just plot these points, okay? And x equals 1, x equals minus 1. So therefore, y is going to be equal to minus 1 over 2 times 1, minus 4. That's going to be minus a half minus 4, which is minus 4 and a half, okay? Minus 9 over 2. Okay? And y is equal to minus 1 over 2 times minus 1, minus 4. That is going to be a half minus 4. Okay? So, we've got our points there, and half minus 4 is minus 3.5, right? All right? Minus 3 over 2. No, minus 3.5. Right? Minus 3.5. Okay? So, we can now plot those points. Okay? Let us now plot our graph, shall we? Okay. The basic bones of the graph. We say, right, we're down here. And let's plot some numbers that we know. Well, first of all, we know that the graph is in quadrant 2, and you plot your minus 4. Y equals minus 4. Then the graph was in quadrant 2 and 4. Remember, it was negative, so it's in 2 and 4, which means we're going to have a graph that does something like that, and a graph that does something like that. The next step is to find that point over there, and hey, we've done it. It's y0, x equals minus 1/8. Minus 1 over 8, and 0, there's a point. You'd plot your 1 over there as well. Now, what about the axes of symmetry? Because we have to put those in as well. All right? Now, let us just draw them. Can you see? And let me put this one in blue. The blue one is going through there like that. Now, the blue one is the line y equals minus x plus q. And the red one is going to be x plus q. Why? Because when we moved the hyperbola, let's just think, we had the standard hyperbola y equals 1 over x. Then we moved it up or down with the q. The axes of symmetry go with it, right? So when we do these, okay, and you've got your graph, you can sketch the axes of symmetry in, and then you just read off what they are. You don't have to remember a formula. This is the line y equals x minus 4. And the blue one is the line y equals minus x minus 4. Because you should be able to see this is going through the point minus 4 over there, isn't it? Okay? So the axes of symmetry move up and down with it, right? Quite straightforward. What I'm going to do, because this one has gone on a bit long, I'll show you how to find the points A and B in the next session. And we're going to do, well, let me just, I just see that this is the only one we've got. Let us find point A and B here. Okay, point A and point B. How do you find the points A and B? Well, what are we looking for? We're looking at where two graphs intersect. We are looking where the line y equals, now read it off, look, okay, read it off. Which is the one that cuts? Oh, it's that one. So that's the one we use. We say y equals minus x minus 4 and y equals minus 1 over 2x minus 4. Well, you put them equal to each other. Minus x minus 4 equals minus 1 over 2x minus 4. You end up with this 4 cancelling out, and you get minus x equals minus 1 over 2x. And what do we do with that? We multiply through by 2x, and we get 2x squared equals minus 1. X squared equals, minus there. X squared equals a half, and therefore x is 1 over root 2 plus or minus 1 over root 2. Okay? Or plus or minus a half, square root of a half, whichever you prefer. So that value there, where they cut, the x-axis value of this guy, let's put it in green, this is minus 1 over root 2, and this value here is plus 1 over root 2. And you go and you find the y value by just plugging it into either one. Okay? And you will find that the x values, okay, I didn't calculate them. The y values of those, you just plug it in. Okay? So you'll have plus 1 over root 2 and the y, and minus 1 over root 2 and the y value that you plug into there. Okay? You would just plug it into your equation of the straight line. Okay? And as I've said, you'll plot 1 and minus 1, which will give you those values down there. Okay? Very easy, very straightforward. Okay? Just follow the recipe with all of these. The next one we're going to do is exponentials, and I said there's a lot more of these that I'm going to do in the exam and test preparations, okay? So when it comes to that for a refresher, you can just go straight there, download them, and we can work them through together on video like we've done with this. I'm going to choose some easy ones, and then obviously just progress. Maybe we'll do 4 of these or 5, where we'll plot each different graph, and we'll come to the answers for it. Sorry that one went on longer than it should. My apologies, but thanks for watching, and I hope that the hyperbola is actually quite a straightforward and an easy graph to draw. Thanks, cheers, bye.